University of Nevada, Reno from 2023 to 2024. We will be demoing is robot localization, mapping, and movement. In order to localize the robot, a global map is created using SLAM mapping techniques and is visualized using the RViz software as seen in the clip. Now that the robot is localized and knows where it is as reflected in the still frame shot, it is time to move on to movement. The RViz software allows us to emulate this movement and tell it where we want it to move and in what direction it will finish in. After it officially finishes its localization, it takes off to the end goal position and point. It chooses the optimal path to get to its goal position, as well as using the LiDAR camera to avoid objects and prevent collisions. Here is a more close-up view of the RViz software as the robot takes the optimal path to the selected goal location and direction. As you can see, the robot knows where it is located on the global map, and it shows itself moving on the display, as well as updating the local map based on any updates or changes. This would not be possible without the LiDAR camera, which came pre-installed on the Highwonder Jet Auto Pro Ross robot. It allows us to detect the objects in its surrounding area, and it is extremely useful for mapping and collision detection as seen in this video, as the robot veers left around the backpack that is laying on the floor. This is pivotal for our project because spaces get messy and the robot needs to be able to navigate around objects such as shoes, wallets, keys, and anything else that may be laying around.
And on the left side is the object recognition. So now the robot starts moving autonomously, and it also sees its surroundings and identifies a couple of objects which are going to then be sent to the user interface.
The UI from any sort of computer or hardware. One of the big technical challenges of this project is memory management. The mapping and object recognition systems use a lot of RAM memory. On the UI side of things, we work to ease this memory use. When the robot detects an object, say a cup, it immediately sends that data over to the UI, where the UI will check on the client-side device how confident the robot is that what it saw is a cup. And so if it's decently confident, then it keeps that data and displays it to the user. Otherwise, it throws that data away. And by doing this, the robot doesn't have to store data about the cup. The only data that's stored over a long period of time on the client side is just the data the user would want to see. The technical tool that helps the UI do all this is called ROSLib.js. It's a JavaScript library that can listen and publish to ROS topics, as well as make ROS service calls. It can listen to the ROS topic from the object recognition system to receive that data, and then we can transfer that into an object.
Once again, we are Team 37, the RoomSense robot. Thank you for watching.